and welcome to the Department of Physics at the University of Oxford. I'm Catherine, and today I'm joined by Professor Mike Glazer, who is a crystallographer. What does that mean? What is it to be a crystallographer?
Well, it means that we study crystals, and in particular what interests us is how are the atoms and molecules arranged inside a crystal, because if we understand that, we can use that information to make new materials which may be of use in industry or in medicine, etc. So what we're about is understanding how the atoms are arranged in a crystal and why they're like that. A crystal is a very interesting object. People have studied these for millennia, but it's only in recent times we began to understand what they are. This is an example of a crystal. It's of a material called fluorite. And if you look at it, it's got these very nice flat faces, and they are in a nice arrangement with one another to form an 8-sided object we call an octahedron. The question is, why would it grow like this? I mean, that's a natural crystal. Those faces grow like that in nature. How do they do that? And so what I'm going to do here is show you a demonstration of how that might occur. To do that, we will use marbles like this to represent an atom or a molecule. And we're going to try and grow a crystal just using these atoms and molecules. Now, atoms want to stick together, we call it bonding. And marbles don't, of course, stick together, but we can use gravity to force the atoms and molecules to come together as if it were bonding. It's a similar kind of idea. Start with a model, and here you see atoms or marbles arranged in a regular array. And if you look, on the bottom here we have 4 triangular sides. It's rather like the bottom half of this octahedron. So this is a representation of a crystal. And the important thing is what we call order, that the atoms and molecules are arranged in an ordered arrangement. They're not just random all over the place. So the question is this: if we were to add more atoms and molecules to this, what would happen? Would we just get a mess or what? So I'm going to ask you to put some more atoms and molecules randomly on here and see what happens. It's over to you.
Okay, so I've got my jug of atoms, my marbles here, and I'm just going to add them.
Voila, it's a miracle. See what's happened? We started with an ordered arrangement of atoms, and it's continued to be ordered. So we start with order, it will grow with order. But in particular, notice it's formed these leaning sides, just like on the bottom. Now, why did it do that? The reason behind this, and it's a principle for all crystal growing, is the atoms want to stick together as close as they can. And if we look at these triangular sides and just work out how close together all those marbles are on those faces, and compare it with where we started, this plane of marbles is much less densely packed together. It's about 15% less. And so this is a principle. Atoms want to stick together as close as they can, and that's why the crystals grow.
So they end up forming these triangular planes because that's better than them just stacking straight flat on top.
Absolutely, that's right. So that's why we have these nice shapes of crystals.